Okay, back at it doing some quick tests. What is interesting this time is before, if you remember, I'll talk out here for a bit. Coming out of that microwave oven transformer right there, yesterday, the day before, was 6.5 volts AC. Okay. And I'm still drawing 130 milliamps, jumping up to 140 milliamps. With the microwave transformer parallel to the run cap phase. I have a 4 UF cap there on the run cap phase. Also, now I've added a full wave bridge rectifier, which is right there. And it has 1080 UF worth of caps on it. And now I added 2500 UF, so it's a total of 3500 UF or MFD, whatever you want to call it, worth of caps on the end of the full wave bridge that's rectifying what's coming out of the microwave oven transformer. I was expecting only about 9 or 10 volts maybe, or, you know, it's because it was 6 volts in AC. And look what I'm getting now. That's 35 volts. And what I want to do is power an inverter like at 15 volts DC. So I need to cut that back down to about 15 volts, and I got just the thing. I'll put a variac between the AC output of the microwave oven transformer and the full wave bridge AC legs. So that should work. Or if I had a transformer that happens to be like step down 2 to 1, something like that. But anyways, I'll use the variac. But this is very surprising that I get 35 volts out of it. I thought there must be something wrong. I thought maybe there was residual current in the residual voltage or joules or whatever inside the cap, and it just hasn't drained. So I switched caps. I have another cap just about the same size. They're high voltage. They go to 350 volts. These are DC caps. They have a positive and negative on them. They aren't AC. They're DC caps. This one and this one. So I switched caps, and it still goes up to 34 volts. So it's 34 volts. So that's kind of good, because I just need to cut it down, not step it up. I think I can use a DC to DC boost converter and hook it up backwards, and it'll kick down the voltage in DC. I'm not sure about that. I don't want to sacrifice one of those right now, but I know they make them that do that, but I don't know if the ones that I have do that. Let me show you. Here's what I got. Over here in the light. If anybody knows, tell me. Here's the input over here. Says in, IN, right there, plain as day. There's negative and there's positive. And here's out over here. So I wonder if I hook it backwards and then twiddle those little blue potentiometers, if I can kick down like that. Not step up, but kick down DC. So anyways, there's a question for you all. So anyways, this is going okay though. I'm not doing a series transformer. Now Warren, he had a Variac as the transformer that comes off the run cap phase in series from L3 to L2. A series transformer, and the transformer was a Variac. That was his first one. And he added the second one in the circuit. And then that, so I guess the second one really isolates everything. And then he rectified it after that. And he ran a DC boat motor with it. And he had more output in DC than output in DC powering it, because he used a little inverter to power it. So he was running it on a battery to an inverter to the RV motor. So anyways, blah blah blah. Here's where I'm at so far. So now I'm going to add a Variac to the mix and get it that voltage in that cap, so it's going to be able to run an inverter. Okay, well, thanks for watching. Okay, bye.